You're listening to AI Podcast. I'm Ethan, and today we're unpacking an ICLR 2025 paper called DeLLMa, short for Decision-Making Large Language Model Assistant. Quick takeaway first. DeLLMa wraps a simple decision theory workflow around a large language model at inference time, and in the author's tests it made choices under uncertainty more reliable and easier to audit than standard prompting approaches.
A clear takeaway helps. So if I remember one thing, it's that adding lightweight structure at inference time helps models make better decisions when the future is uncertain.
Exactly. The work is led by Ollie and Deqing at the University of Southern California with colleagues, and it appeared at ICLR 2025 as a spotlight.
All right, what problem are they tackling in everyday terms?
Think about decisions where outcomes depend on unknowns. Should a farmer plant this fruit given weather and market swings? Which stock looks best for the next few weeks? Typical prompts can sound convincing, but they aren't built to weigh uncertain futures or to align choices with the user's goals. The gap here is to make the model enumerate the unknowns, estimate how likely they are, define what the user values, then choose the action that maximizes expected benefit.
So they nudge the model to think like a careful decision maker, not just a fluent writer.
That's the idea. The approach is explicit and auditable. Step 1. List the uncertain factors that matter for the decision. Step 2. Forecast those unknowns given the context. Step 3. Spell out a utility function that reflects the user's goals. Step 4. Pick the action with the highest expected utility. Because each step is written out, you can see which states the model considered, the probabilities it assigned, and how it scored each option.
I like the audit trail. People want to know why a recommendation was made. How does this differ from familiar tricks like chain of thought or self-consistency?
Those techniques encourage longer explanations or multiple samples, which can help on clean logic problems, but they don't force the model to reckon with uncertain states or with a utility function. DeLLMa keeps the same base model and adds that decision theory scaffold at test time. No retraining, just structure that changes the kind of reasoning the model has to do.
What did they actually test to see if this works?
2 realistic but controlled settings. First, agriculture planning. The model reads excerpts from United States Department of Agriculture fruit market reports, along with recent price and yield statistics from California, then chooses a fruit to plant for the coming year. Second, short-term stock selection. The model sees 2 years of monthly prices for a small set of well-known tickers and has to choose one to buy at the start of December 2023 and sell at the end of that month.
Nice contrast. One task leans on narrative reports, the other on simple tabular context. How did DeLLMa compare to standard prompting?
They compared against zero-shot prompting, chain of thought, and self-consistency. They also tried a couple of DeLLMa variants. One variant learns utilities from full pairwise comparisons among sampled state action pairs, and another uses only the top choice from each batch of comparisons. Across both domains, the DeLLMa variants consistently outperformed the baselines, with the gains more noticeable as the decision set gets bigger or the uncertainty gets messier.
So there are trade-offs. Does more structure mean more compute at inference time?
Yes, there's a knob you can turn. The method samples and compares state action pairs to estimate utilities. If you generate more samples or reuse them carefully across actions, decisions improve, but you do spend more inference time compute. The results show a predictable improvement when you allocate a bit more test time budget, which is useful because you can dial it based on cost and latency.
And how about calibration? Do their probability forecasts look at least reasonable, not wildly overconfident?
They include checks showing the forecasting step is reasonably calibrated in context, and they run a small human study to see whether the learned utility preferences align with human judgments. The broad takeaway is that the scaffold pushes the model toward more disciplined, transparent reasoning, and a good portion of the intermediate choices align with human preferences.
Let me try a plain language recap. The structured approach beats typical prompting on the 2 test beds. And the gap grows when the decision depends on juggling several unknowns. If you let the model sample and compare a bit more at test time, it gets better, within reason, and you get artifacts you can audit afterwards.
That's a fair summary. A practical note as well. The team provides a project page and code so others can inspect prompts, data processing, and the scaffold itself, which helps with reproducibility.
Okay, now for the cautious view. What should we keep in mind before applying this to something like hospital triage or city budgeting?
A few things. The evaluation focuses on 2 compact domains with small action sets. That's a good starting point, but larger and messier environments will need more careful state enumeration and better tools for forecasting. The method assumes you can list the important unknowns within a prompt, which may be the bottleneck in very complex problems. And the stronger variants do spend more tokens, so cost and latency matter in deployment.
So it's not a magic wand. It's a disciplined wrapper that shines when decisions are discrete, the unknowns can be named, and you can afford a bit more inference time reasoning.
Exactly. Looking ahead, there are clear extensions. Moving from single-step choices to multi-step plans where today's action changes tomorrow's state. Coupling the forecasting step with external tools like retrieval or time series models to ground the probabilities. And using stronger human-in-the-loop protocols for eliciting utilities in safety-critical settings.
That would help in areas where values are more nuanced than just profit. And because the scaffold record states probabilities and utilities, teams can review those artifacts during audits or incident analysis.
Right. That traceability is a practical benefit. Even when the model makes a mistake, you can see where the reasoning went off, which you rarely get from a one-shot prompt.
Before we wrap, could you repeat the lead authors so people can look it up?
Led by Ollie and Deqing at USC, the paper is called DeLLMa, and they pronounce it like the word dilemma.
Great. Today's takeaway, if you want language models to make decisions under uncertainty, don't just ask for a final answer. Ask them to enumerate unknowns, forecast, elicit the utility you care about, and then choose the action that maximizes expected utility. That's DeLLMa in a sentence.
Well said. That's it for this episode of AI Podcast. If you found this helpful, share it with a colleague who's exploring decision support with language models. Thanks for listening.
Thanks, everyone. See you next time.